Right, straight into question 3. In this bizarrely trigonometry-heavy start to the paper, it's weird, isn't it? Having done question 1 about trigonometry, we're straight into it again. Question 3. The diagram shows a sector OAB of a circle, centre O, radius 12. The angle AOB is 2/3 of pi radians. Find the exact length of the arc AB. Right, first thing is, we must not be tempted to change angles in radians here into degrees and try and go back to doing it in degrees. We've learnt the arc length and the area of a sector if the angle is measured in radians. So when we do part 1, the exact length of the arc AB, well, arc length is r theta. We've learnt that, providing that theta is in radians, and it is, so that is 12 times 2/3 of pi. And notice what it says. Exact length is what's required. So that means don't give a decimal answer at any stage, don't give a decimal answer. So it is 12 times 2/3 times pi, so that's 8 pi. That's the only acceptable answer. Okay, your answer of, was it 25.1 or something like that, if you do pi times 8, is no good. Even if you've written 8 pi, and you then write it, it's no good. You'll lose the value that you got from 8 pi. The second part, but we've done this so many times. Again, it's saying, let's highlight that, again it's saying exact area, but this thing of a shaded segment is one of those standard things. You can either remember a formula for it, which is half r squared brackets theta minus sine theta. That's one way to remember it. Or you could do the 2 parts separately and subtract them. The sector, remember, the sector is a half r squared theta. So that is half times 12 squared times 2/3 of pi. Again, because we want an exact answer, it's really important that we don't jump into a decimal for this. This is 48 pi. We can do it exact, so we keep it exact. The next bit, the triangle, the kind of unshaded bit that we're going to subtract is a half r squared sine theta. So that is half times 12 squared times sine 2/3 of pi. Now this we need to be a little bit more careful about, because we want our calculator to be in radians if we're going to do it in, work it out in radians. And we want to get an exact answer, so we need to make sure that we get now it's 36 times root 3. Sine of 2/3 of pi is root 3 over 2, and so then we're doing, what's that? That's root 3 over 4, times it by the half. So we're doing 144 divided by 4, which is 36, times the root 3. There we go, we're keeping them exact. And so the shaded area that we want is what we get if we take the bigger area, the sector, 48 pi, and we subtract 36 root 3. And the question said, find the exact area. So if you've got that, that's your answer. Leave it like that. You can't combine that in any way. If you then write that as a decimal, then you lose the mark for it. And it was amazing how many people on this question, which was worth 7 marks, how many people got 5? And 5 marks was what you got if you did everything right, all of this perfectly, and then at the end of each answer you wrote it to 3 significant figures. And that resulted in 5 out of 7, just for doing that. Okay? If the question says exact, let's make absolutely certain that we give our exact answer. And that's maths.